So far, what kind of transformations have we done? Who can tell me one? Rotations. That was yesterday in 7.3. What else? Reflections. That was our first day. Yeah, what do we call them? And that's transformations is the whole unit. It starts with a T. Yes? Yes? Good. Translations. Translations. I like how Michael said that. It has X and Y axis movement. Cool. So today we're adding in dilations. And this is all on your test on Friday. So today we're going to add in dilations. So today I can change. I didn't write an Eichmann statement. Today I can dilate a point in shape and write/use a dilation rule. So it's going to look very similar to our translation rules, but dilations involve multiplication, not adding or subtracting. Okay? A transformation, right? It's a change in a figure's position, shape, or size. So a transformation, which we just listed the 4 transformations, it's a change in a figure's position, shape, or size. The symbol we use to represent that is an arrow. So an arrow is saying it's changed from this to this. Again, some of this is review. The pre-image is what? How would you describe the pre-image? The original shape or point. So in this example, I know we've talked about this vocab, but it's good to review the vocab because there's a vocab section on your test. So let's say we took triangle ABC. What would the transformed notation be? Triangle what? A prime, B prime, C prime. We would add these notes. In this example right here, we have dilated the shape. Do you see how it got larger? It got larger. So this is a example of a dilation that we'll be looking at today. The image is the final shape and position. And now we'll start defining dilations. A dilation is an enlargement or a reduction of a shape. Enlargement or reduction of a shape. I'm also going to add in or line segment. We have problems where we shrink or enlarge a line segment. Multiplication. So a scale factor, it describes the size change from the pre-image to the image. And then we'll start getting into what is an enlargement, reduction, and the rule, and we'll do some examples. Anyone still writing? Yeah, no worries, no worries. The scale factor. So a number greater than 1. Greater than 1. When you're looking at this, the preimage is smaller than the image. So on your test, we might give you the preimage and the image, and you have to tell us what has happened, an enlargement or a reduction. What would you guess about the number for a reduction? For an enlargement, it's a number greater than 1. Less than 1. The scale factor or the number has to be between 0 and 1. Why between 0 and 1? What if I went less than 0? What happens when you go less than 0? Negative. Yeah, we're not going to use a negative scale factor. This preimage is bigger than the image. And now we're going to get to the dilation rule. Dilation rule. Like we do with all the rules so far, we're going to start with some point a x comma y. The dilation is always going to be centered at 0, 0. Okay, so we're not doing any dilations around lines or other points. It's always going to be dilation around 0, 0. And we've got a scale factor n. Okay, n is going to represent the scale factor. The dilation rule can be written as follows. It's going to be n times your x, n times your y. And the two numbers are always going to be the same. We're always going to be dilating x and y by the same scale factor. Again, n is the scale factor. You ready to try it? No. Here we go. Here we go. In example 1, we need to find the scale factor, identify if it's an enlargement or reduction. So we have to say what it is and the number. It's important that we read. We lost a lot of points on that Unit 6 test because we weren't reading the instructions. So, first off, we should probably identify what's the preimage and what's the image. This shape looks a little crazy because I've got a triangle within a triangle. Where's the preimage?
Little triangle.
It's this little guy. It's ABC. Okay. Has it enlarged or reduced? So you can write enlargement or you can say it's gotten bigger. You don't have to write out enlargement. You can use bigger. And now I need to figure out the scale factor. So this side, AC, is 7 units long. What is the total for A prime, C prime, right? AC is 7. A prime, C prime is, look closer, 28. So what have I multiplied this by? 7 times what? 4. So my scale factor is 4. We did it. We did it. Are we seeing the preimage and the image for this next one? B. What has happened? Where's my preimage? The bigger one, right? So it went big to small. So do we have an enlargement or reduction? Reduction. And remember, you have to write that. I'm going to look for a line segment so I can use the units. Okay, I'm going to look for a line segment. I'm going to use AD. Count how long AD is. 1, 2, 3, 4, 5, 6, 7. Segment AD is 7. I'm going to find the same line segment, A prime, D prime, in the smaller shape. And now I'm going to count how big that is. 1, 2, 3, oh my goodness, and a half. It went from 7 to 3.5. What am I timesing by? I'm dividing by 2, but I have to say it in multiplication. My scale factor has to be less than 1. What's the same thing as dividing by 2? Multiplying by a half. We have times by a half, if you don't believe me. In your calculators, do 7 times half, or 0.5. You should get 3.5. You ready? Next page. Flip it. Next page. Flip it. Oh no. Now you have to draw them in using dilation rules. Oh my goodness. Look at that fraction. Panic. Ah! All right. Let's start with A. A. Oh, is it snowing? We all have to stop. An enlargement by what? 3. Let's write out all the points for A, B, C. Where is A? Got to know how to read a graph. Where is A? What's the coordinate? 1, 2. Write it down. Where's B? Okay, what's C? Great. To find point A, I'm going to times the coordinate by 3. So I'll show my work. Here we go. 1 times 3, comma 2 times 3. So my new point is 3, 6. I'm just timesing each coordinate by 3. That's the rule. And then I'm going to graph it. Let's just get all our coordinates first. What's negative 1 times 3? Oh my goodness, what's 0 times 3? 0. Okay. What's 2 times 3? 6. What's negative 1 times 3? 3. Let's regraph it now and label it with A prime, B prime, C prime. Oh, okay. 1, 2, 3. Up at 6. 5, 6. Here's A prime. You have to graph. You have to label. 2, 3. B prime. 6, negative 1, 2, 3, C prime, and then connect the dots as close as possible. And we're going to say this was an enlargement. All right, let's just leave the fraction one for you to figure out, huh? What? No, I'm just kidding. I'm just kidding. We're not going to we'll do the fraction one together. You will want a calculator, though. A calculator. We're going to start by writing out the points. A, B, and C. You grab a calculator. 2, 4. This is 1, 2.
Hunter, I was over here on
All we had to do is get a calculator. By all of our points by 1/4 or 0.25. I'm going to show my work up here. I'm going to take A and times each coordinate by 1/4 or 0.25. And we get half for x coordinate. 2 times 1/4 is 2/4, which is equivalent to 1/2. Again, 1/4 is equivalent to 0.25. So you're welcome to type this in with your calculator with a decimal.
How do you graph a half?
You go in the middle. In the middle. You should get 1 for the y coordinate. B, This is going to work out nicely. Negative 8 times 1/4 is negative 2. 2 times 1/4 is, we just did that, it's 1/2. C is where it gets crazy. You're going to get some decimals. So do 6 times 0.25. What do you get in your calculator? 1.5. Do 3 times 0.25. What do you get? And this should be negative. Negative 3. Negative 0.75. Oh no. And now we're going to graph it. Approximate the best you can. Half. 1. Here's A prime. Negative 2. 1, 2. Half. And C is at 1.5, negative 0.75. So here. Cool. Questions? Very similar. Let's talk about making a ratio based off of A. If A is at 22, negative 18, we transform it, and now it's at 33, negative 27. Has the segment gotten larger or smaller? Larger. And then I'm going to use my x values here. I'm going to use my x value from my A prime and my x value from my preimage. And I'm going to do 33 divided by 22. I multiply to use my scale factor. To find a scale factor, we should divide. So you've got your calculators out. Do 33 divided by 22. 1.5. Let's confirm the scale factor. So now let's do the y's. I'm going to take my A prime y value and divide it by my regular A y value. Do negative 27 divided by negative 18. Do we also get 1.5? Check it in your calculator. So we have a scale factor of 1.5. Now I have to finish the question. What are the coordinates of B prime? So what do I do with B? 8, 14. What should I do? Multiply. So do 8 times 1.5. 14 times 1.5 to get our B prime. What is our new B prime? Get your calculator going. 12, 21. Not so bad. Divide to find the scale factor if you know the preimage and the image of 1 point. Okay? Homework time. Homework. Numbers 1 through 5 in your homework packet. Ready, set, go.